Hold your hand in front of your face. Spread your fingers. Look at your palm. Right now, inside that hand, potassium-40 atoms buried in your bones are decaying, and each decay releases something that shouldn't be there, a positron, a tiny piece of antimatter. It exists for less than a billionth of a second before it collides with an electron, and both of them vanish in a flash of pure light. Your body is creating and destroying antimatter right now. You can't feel it. You will never feel it. But it is happening between your bones as you listen to this, roughly 4,000 times a day. And here's what nobody tells you. Antimatter was never supposed to exist. It was discovered by accident, predicted by an equation that its own creator thought was broken. The physicist who wrote that equation believed he had made the worst mistake of his career. He hadn't. And the reason why he was wrong doesn't just change how we understand particles. It changes how we understand time itself. But before we get there, I need you to forget everything you think you know about antimatter. Forget the science fiction. Forget the warp drives and the weapons and the glowing containers in movies, because the real story of antimatter is stranger than any of that. It starts with a 25-year-old sitting alone in a room in Cambridge, staring at a piece of paper, realizing that his math was telling him something impossible. The year is 1928. Paul Dirac is trying to solve a problem that has been haunting physics for 3 years. Quantum mechanics works. Einstein's special relativity works. But nobody can make them work together. The equations describing how electrons behave break down the moment you try to account for the fact that electrons can move close to the speed of light. Schrödinger's equation, the crown jewel of quantum mechanics, simply does not function at relativistic speeds. It's like having two maps of the same city that flatly contradict each other. Dirac does something audacious. He writes a new equation from scratch, not a modification of Schrödinger's equation, a completely new mathematical object, and it works. It describes the electron perfectly at any speed, but there is a problem. The equation has two solutions. One describes the electron exactly as expected. The other describes a particle that has never been observed. Same mass as the electron, same spin, but with a positive charge instead of negative. And worse, it seems to have negative energy, which in 1928 is a concept so strange that even Dirac doesn't know what to do with it. He is so uncomfortable with this second solution that he tries to explain it away. Maybe, he suggests, this mystery particle is actually the proton. This is a desperate move, and he knows it. The proton is 1,936 times heavier than the electron. Claiming his equation predicted the proton is like saying your recipe for a cupcake accidentally produced a wedding cake. The numbers don't match. Other physicists point this out immediately. Dirac quietly abandons the proton idea and admits what his equation is actually saying. There must be a particle out there, identical to the electron in every way, but with the opposite charge, an anti-electron. Nobody believes him. For 4 years, the anti-electron exists only on paper, a ghost in the mathematics. Then, in 1932, a 27-year-old physicist named Carl Anderson is working at Caltech with a device called a cloud chamber. Cloud chambers are beautifully simple. You fill a chamber with supersaturated vapor and place it inside a strong magnetic field. When a charged particle flies through, it leaves a visible trail of condensation, like a tiny jet contrail, and the magnetic field bends that trail. Positive particles curve one way, negative particles curve the other. The amount of curvature tells you the mass. Anderson isn't looking for antimatter. He's studying cosmic rays, high-energy particles raining down from space. One day he sees a track that makes no sense. It curves the wrong way for an electron, but the curvature is too tight for a proton. It has the mass of an electron and the charge of a proton. He photographs it, he measures it, he checks his equipment, he checks it again. There is no mistake. He is looking at Dirac's impossible particle, the positron, the first antimatter ever observed by a human being. Anderson wins the Nobel Prize in 1936. He is 31 years old, and physics will never be the same. Now here's where most people stop the story. Antimatter was predicted, antimatter was found, neat. But that's not even the interesting part, because the real question isn't whether antimatter exists. The real question is what it means that antimatter exists. And the answer to that question is far more personal than you think. There's a reason hospitals use antimatter every day, and nobody has told you. And it connects to something unsettling about what is happening inside your body right now. You've probably heard of a PET scan. Maybe you've had one. PET stands for positron emission tomography. Read that again. Positron. Antimatter. Here is how a PET scan works. A doctor injects you with a radioactive tracer. That tracer emits positrons, anti-electrons, inside your body. Each positron immediately meets a regular electron in your tissue. Both particles annihilate. They cease to exist, and in their place, two gamma rays shoot out in exactly opposite directions. The scanner detects those gamma ray pairs and uses them to build a three-dimensional map of your organs. Approximately 2 million PET scans are performed every year in the United States alone. Antimatter annihilation, the same process that powered the earliest moments of the universe, is happening in hospital basements right now to diagnose tumors and heart disease. This is not exotic. This is Tuesday in radiology. And your body doesn't need a hospital to produce antimatter. The potassium-40 in your bones undergoes beta plus decay naturally. Every day your skeleton generates roughly 4,000 positrons. Each one exists for a fraction of a nanosecond before finding an electron and annihilating into a pair of photons. Your body is producing and destroying antimatter right now. You just can't feel the annihilations. Stop and think about what that means. The thing you were taught was the most exotic substance in the universe is being manufactured inside your femur as you sit there. But this raises a question that's far more troubling. When a positron meets an electron and they annihilate, both particles disappear completely. Their entire mass converts to energy, and the efficiency of that conversion is unlike anything else in physics. Nuclear fission, the process that powers nuclear reactors and atomic bombs, converts about 0.1% of mass into energy. Nuclear fusion, the process that powers the sun, converts about 0.7%. Matter-antimatter annihilation converts 100%. Every bit of mass gone, turned entirely into energy. E equals mc squared at its absolute maximum. 1 gram of antimatter meeting 1 gram of regular matter would release an explosion equivalent to roughly 43 kilotons of TNT. The Hiroshima bomb yielded about 15 kilotons, so 1 gram. Not 1 kilogram, 1 gram, 3 Hiroshimas. And here's the thing that should keep you up at night. CERN, the largest and most sophisticated particle physics laboratory on Earth, has produced roughly 20 nanograms of antimatter in its entire operational history, 20 billionths of a gram. At current production costs, a single gram of antihydrogen would cost approximately $62.5 trillion. We can make it. We just can't make enough of it to do anything dangerous with it. Not yet. But the physics doesn't care about our limitations. The physics says that if a particle of matter touches its antiparticle, both disappear and release everything they are as light. If you're the kind of person who needs to know what's actually going on, not the simplified version, not the textbook version, but the version that makes physicists lose sleep. Subscribe. Because what Richard Feynman proposed next is something that most people never hear, and it changes everything. So, Dirac predicted antimatter. Anderson found it. We know it's real. We use it in hospitals. We know it annihilates with perfect efficiency. But nobody has answered the deeper question: why does antimatter exist at all? What is it really? Why does every particle in the universe have an antiparticle twin? In 1940, a phone rings. A young Richard Feynman, still a graduate student, picks up. On the other end is his advisor, John Archibald Wheeler. And Wheeler says something that sounds insane. He says, "Feynman, I know why all electrons have the same charge and the same mass. It's because they are all the same electron." Wheeler's idea goes like this. Imagine a single electron zigzagging back and forth through time. Moving forward, it's an electron. Moving backward, it's a positron. Forward again, electron. Backward again, positron. One particle weaving through every point in the history of the universe, creating the illusion of trillions of separate particles. Every electron you've ever encountered, every electron in your body, every electron in every star, the same one, passing through on its endless journey. Feynman immediately spots problems. If one electron is bouncing back and forth, there should be exactly as many positrons as electrons in the universe, and there aren't. There's far more matter than antimatter. So the one electron universe can't be literally true. But Feynman doesn't throw away the core insight. He takes Wheeler's backward in time idea and builds something extraordinary with it. In 1948, he publishes his framework for quantum electrodynamics, introducing what we now call Feynman diagrams, the visual language of particle physics. And in those diagrams, an antiparticle is drawn as its particle moving backward in time. A positron is not drawn as a separate thing. It is drawn as an electron with its time arrow reversed. And here's what will break your brain. This is not a metaphor. It is not a teaching shortcut. It is not a simplification for students. It is mathematically identical. Every equation that describes a positron moving forward through time produces exactly the same result as an equation describing an electron moving backward through time. You cannot tell the difference. Not with any experiment, not with any measurement, not with any instrument ever built. The math says they are the same thing. Let me say that differently, because I don't think the full weight has landed yet. Antimatter is not the opposite of matter. It is not a mirror image. It is not a different kind of stuff. According to the mathematics that every particle physicist on Earth uses every single day, antimatter is ordinary matter traveling backward through time. Antimatter isn't the opposite of you. It's you, moving the wrong way through time. Feynman received the Nobel Prize in 1965, partly for the development of these diagrams. They are not controversial. They are not fringe. They are the standard computational tool of quantum field theory. Every calculation of how particles interact, every prediction tested at CERN, every confirmation of the Standard Model, all of it uses Feynman diagrams. All of it represents antiparticles as particles with reverse time arrows. This is not speculation. This is the framework. And if that already disturbed you, hold on, because the implication goes further than particles. It goes all the way to why you exist. In the first fraction of a second after the Big Bang, the universe was a furnace of pure energy. As it cooled, that energy condensed into particles. And the laws of physics, as far as we understand them, say that matter and antimatter must be created in exactly equal amounts. For every quark, an antiquark. For every electron, a positron. Perfect symmetry. And then, almost immediately, those particles found their antiparticles and annihilated. Matter met antimatter, and both were converted back into light. Nearly everything was destroyed. Nearly. For reasons that nobody can fully explain, the symmetry was not perfect. For every billion antimatter particles, there were 1,000,000,001 matter particles, one extra, out of 1,000,000,000. That tiny imbalance, that rounding error, meant that after the great annihilation consumed 99.9999999% of everything that had been created, a tiny residue of matter was left behind. That residue became every galaxy, every star, every planet, every ocean, every tree. You. Everything you have ever seen, touched, loved, or lost exists because of that one extra particle per billion. You are what survived the greatest destruction event in the history of the universe. Not because you were strong, not because you were special, but because the symmetry was slightly broken and no one knows why. The observed baryon asymmetry is approximately 1 part in 10 billion. In 1967, the physicist Andrei Sakharov outlined 3 conditions that must be met for this asymmetry to have occurred. One of those conditions, CP violation, was confirmed experimentally by James Cronin and Val Fitch at Brookhaven in 1964, when they showed that neutral kaons decay asymmetrically by approximately 0.2%. They won the Nobel Prize in 1980. But even with CP violation confirmed, the amount of asymmetry it produces is nowhere near enough to explain the amount of matter in the universe. Something else happened, and we don't know what. You are the rounding error of an annihilation that destroyed almost everything. That's not poetry, that's the current state of physics. In 2010, the ALPHA experiment at CERN trapped antihydrogen atoms for the first time. In 2016, they measured the spectral properties of those atoms. In 2020, they measured the 1s, 2s transition frequency of antihydrogen and found it consistent with regular hydrogen to a precision of 2 parts in 10 to the 12th power. Antimatter atoms behave identically to matter atoms. The symmetry is almost perfect, which makes the fact that it was broken even more mysterious. Think about what that means for a moment. The machine in the hospital that images your brain tumor works by triggering the exact same process that almost erased the universe. Matter-antimatter annihilation producing photons. The technology in your hospital basement is a controlled reenactment of creation and of destruction. Every PET scan is a tiny echo of the Big Bang performed at room temperature between your ears. And Feynman's diagrams, the ones that describe all of this, work equally well in both directions of time. The equations do not care whether time flows forward or backward. At the quantum level, the arrow of time, the thing you experience is the difference between past and future, between birth and death, between a memory and a plan, is not written into the fundamental laws. It emerges from something else, something deeper. And antimatter is the proof that the deeper level doesn't distinguish between before and after. Feynman said antimatter moves backward through time, but that raises a question nobody can fully answer. Why does time move forward in the first place? Why do you only experience one direction? That question leads to something called the arrow of time, and it connects to entropy, the Big Bang, and the same asymmetry that let matter survive antimatter. In another video, I followed that question to its source, and what I found at the bottom of it is something physics still cannot explain. If you want to keep going, it's right here. Now look at your hand again. Those annihilations happening inside you right now, 4,000 times a day, each one is a tiny echo of the event that created everything. A particle of matter meeting a particle of antimatter, both vanishing into light. The same process that 13.8 billion years ago consumed almost everything in existence. Your hand is here because that annihilation was imperfect. You are here because the destruction was not total. Every positron vanishing in your bones right now is a reminder. You are what's left when almost everything was destroyed, and no one knows why you survived.